All right, so again, the use of a calculator is super important. We've kind of used it a little bit here and there, but there's three main things that you're really supposed to be using the calculator for that College Board expects you to. Number one is solving equations. Number two is finding numeric derivatives. And then number three is going to be finding later on numeric integrals, okay? But there's a lot of other things the calculator can do for you. And she kind of wrote this up based upon some of the stuff she got at the Summer Institute, which is pretty fresh stuff. So I thought I'd share it with y'all. I usually don't really go heavy on the calculator until like towards the end of the year. But you know, it doesn't hurt to kind of get comfortable with it now. All right, so these are all free response questions, but your test will have some multiple choice and free response. So I'll just have y'all, and I'll say this when y'all turn in y'all's take-home test, it'll be show work for the multiple choice. All right, so particle moves along the x-axis. Its velocity is given by this. Okay, so that's a pretty funky looking equation. For 0 less than or equal to t less than or equal to 3.5. So it's only good for that 3.5 second span. And then the particle is at position -5 when t equals 0. So that's kind of leading into something that we'll be doing later on in the year. But anyway, find the average acceleration of the particle during the first 3 seconds. All right, so notice it says average acceleration instead of instantaneous. So it's not a derivative question. And during the first 3 seconds. So first thing you want to do is identify the interval of time. So that's from 0 to 3 seconds. And anytime you have a calculator question, whether it's multiple choice or free response, you want to show your setup, okay? You got to show your setup. So here's what we're going to write. We're going to write average acceleration. Average acceleration is the average rate of change of velocity. Bless you. Now notice the velocity has a name already, a distinctive name, v of t. So all you have to write is v of 3 minus v of 0. That's going to be the change in velocity over the change in the corresponding time. So that's your difference quotient. That would earn a check. And again, if you're not sure if that's going to give you the right answer, look at the units. The units of velocity are in feet per second, and the units of the bottom are seconds. Feet per second divided by second is feet per second squared. Now, you don't have to evaluate this, you know, by hand. You know, free response, you could just plug in your 3 and leave it. But I'm going to show you how to use the calculator to let it do all of this for you, okay? And we're just going to write down the answer. So go to your calculator, turn it on, go to y equals. You can use the y equals not just for sketching the graph of something, but for being a placeholder for a function. So first thing you want to do, since you know you're going to be typing in a sign, is check your mode. You should always be in radian mode in here. And if you reset your calculator, it should be on the left-hand side, radian mode. Okay, good. Now we'll go back to y equals, and we're going to set up this quotient. So alpha y equals, enter. Always use the horizontal division bar. We get 10 sine of 0.4. And your calculator doesn't care if you're using t's or x's or q's, whatever. It's t on our paper, but since there's a shortcut, we'll just use x. It's always easier to use x squared, close parentheses, and then in the bottom, x squared minus x plus 3. So click to the right, double check, make sure it looks exactly like it is on your paper, except for the variable, right? T and x. And we don't hit graph. We don't care about the graph. We're just using it to refer to it, okay? Now, here's what else you could do, by the way. If you type this into Y1, it already has a distinctive name called V, but it doesn't hurt to come off to the side and also call it Y1 or Y sub 1 if you want. Give it another name, right? It can have 2 names. And that's a reminder to you where you put it, because sometimes you might have 2 or 3 equations in there. One in Y1, one in Y2, one in Y3, and you need to keep track of which one's in which. So now hit second mode, get back to the home screen. And now, since we've shown the difference quotient, Now we can type it in from the home screen just like that, alpha y equals, and then to recall your function that's in y1, we hit alpha trace. Alpha trace is your shortcut, and we have it in y1, so we'll select enter, open parentheses, 3 close parentheses. So I think we've done this already this year. This treats it as function notation. Minus, do it again, alpha trace, number 1, at 0. And then the bottom, I know 3 minus 0 is 3, but I'm just going to write it as 3 minus 0 so that it looks the same. Now, you don't have to write any intermediate values down, okay? Because if you did, you might get rounding error at the end. You should never, ever, ever, ever use a rounded or truncated answer, an approximated answer that you came up with yourself for any subsequent calculation, ever. Because if you're off in the third decimal, you're wrong, all right? So this is a good way to let the calculator do all the heavy lifting. And there it is. It's negative 0.163, or you can round negative 0.164. But always 3 decimals, round or truncate. Now, if there were units, I don't think she actually had units on here. She has units of time during the first 3 seconds, but there are no units of velocity. I said feet per second. If there were, let's just call it feet per second and seconds. Okay, if that were the case, then you would put feet per second squared. So you always want to include units on any final numeric answer, on your dependent output variable. And then if you ever write a sentence, you have to have both units on the independent input and the dependent output. All right, and that's it. Easy enough, right? That's letter A, average acceleration. All right, part B, find the velocity of the particle at 3. That's the instantaneous, right? At t equals 3. And then explain what that means in terms of the particle's position. All right, first things first, notation. Velocity at 3, well, I have the velocity function, so I'm just going to put v of 3. And then from the home screen, I'm just going to go alpha trace at 1, open up 3, close it, hit enter. Negative 0.491. You'll see that I'm a big fan of truncating. And if that were our final answer, we'd put feet per second. All right, so now we got to write our sentence in terms of the particle's position, okay? So we would say at t equals 3 seconds, comma, the particle's position is whating? Increasing or decreasing? Decreasing by, and now here's where we answer with the magnitude only, positive 0.491 feet, and then per second. So whenever you talk about the position, you make sure you answer it in position units, PER per time. Okay. If this thing were moving, it is moving horizontally. So if it asks you to say it in terms of the particle speed, you would just say t equals 3 seconds. The particle is moving left at 0.491 feet per second. And you could answer in feet diagonal seconds. Okay, moving left at a speed is the same as the particle's position decreasing. All right, so far so good. Nothing to it. Bless you. When does the particle change directions justify? Okay, so we know that that's going to be when the velocity changes signs. In theory, a velocity doesn't have to pass through 0 in order to change signs. In the real world, it does, right? You can't change your sign of your velocity in the real world in directions without first passing through 0. Even like atom smashers, where particles are smashed into each other and they change directions rapidly, they still do so by passing through 0. Okay, but in theory, it doesn't need to. So the first thing that you're going to want to do is now sketch a graph of this function, and on the interval from 0 to 3.5. So for the first time, we want the graph. So let's go ahead and do that. We go to Zoom 6 is a good place to start, but we can do better than that. Let's do zoom, or go to your window, and we're going from 0 to 3.5. That's important on your input. You don't want to be tempted by outside values. 0 to 3.5. It doesn't matter what you count by. X scale can be 1. Yeah. Now, because we're going to be looking, what's that? Oh, okay. This one will pass through the x-axis because the numerator is a continuous function. So negative 10 to 10 is not bad. Let's see what that looks like. There you go. You see it cross the x-axis. Now, what I would recommend typically is if you know you're looking for it to cross the x-axis through a continuum, then you're going to want to possibly change your scale on your y min, y max. Negative 10 to 10 is default, but like negative 3 to 3, you know, is what I like because that already stretches out the axis, but it keeps the x-axis in the middle. Now go to y equals. We do want to find the x value where it crosses. It's a lot easier to find points of intersection on your calculator than it is to find zeros. It's a lot faster. So anytime you're looking for a solution on the x-axis, go ahead and get in the habit of graphing y equals 0 in y2 or 3 or wherever you have room for it. Now when you hit graph, that's not right. Yeah, my window, I went from negative, I meant to go from 0. Yeah, there we go. 0 to 3.5. See how it crossed to the left? And I don't want to be tempted by that. There it is. And then it just grabs 0. We don't see it unless you have a color screen, right? Second trace number what? Instead of doing number 2, we can use number 5 since we graphed it. And it'll automatically put you on each of the 2 curves if you have them both graphed. First curve, hit enter. Yep. Second curve, yep, hit enter. And then for your guess, if there's only one point of intersection on your window, you don't even have to scroll close to it. That's really important if it intersects more than once that you find the one you want. There it is. And there's our answer. So we'll go ahead and write the equation we're solving. That's important. I do want to know now where v of t equals 0. So always show the equation you're solving. This happens when t equals 0.2. I'm sorry, 0.2802. And that's the numeric answer. So we'll put seconds. And then if you leave that as your bottom line, you're stating that as your answer. And it says to justify. Okay. Let's go ahead and write the sentence then. Changes direction at t equals 2.802 seconds, comma, because v of t changes from what to what there? Positive to negative. Good. Changes from positive to negative. You could either say at that point or here, or I like to just say at t equals 2.802 seconds again. So it does feel maybe repetitive, but you're actually saying here's where it happens because that's the exact same place where the sign of v of t changes in this particular manner. Now, just because a velocity is equal to 0, does that mean that it has to change direction? No, I can walk towards the door, stop, continue walking towards the door. I don't have to change direction. So it's more than just v of t equaling 0. It has to pass through 0 if it's through a continuum. So that's why there's a difference in saying t equals 2.802 seconds underneath v of t equals 0, and then answering the question over here. All right, now for what it's worth, is the particle changing from going right to left or left to right at this point? Right to left, good, because right before that value, the velocity is positive, so position's increasing, it's moving to the right. And immediately after that, velocity is negative, so it's moving to the left. Good. Oh, if you turn it sideways in the right direction. Yeah, yeah, that helps. Yeah. Yeah. Positive, yeah. Positive to negative, positive velocity to the negative velocity is right to left. Okay, find the acceleration at t equals 3. Acceleration at t equals 3. That's instantaneous now, right? Here's all you have to do. V prime of 3. Now, I'm going to rename that. I'm going to go ahead and call that A of 3, just because that allows me to define now the acceleration function. But here's what we're going to do. On a calculator question, you're not expected to use the Hody High rule and then plug it in. You just put V prime of 3, and that indicates your method. And then you go straight to the home screen. You remember how to take the derivative of something from the home screen? Math 8. Good. Math 8. There might be other shortcuts, but math 8 is the end derivative, math 8. And then it shows up like this. So we're taking the derivative with respect to x of our velocity function, right? Which is still in y1. So alpha trace number 1. And then over here, evaluated at x equals 3. That's all you have to do. You hit enter, and then you write it down, negative 2.118. And that would be feet per second squared. Explain the meaning in terms of the particle's velocity. Okay. So final answer always gets units. And now we'll say at t equals 3 seconds, comma, the velocity is whating? Decreasing, good. By positive 2.118. And then remember, since we're talking about velocity, it'll be feet per second. And then you write out per second. Those units have to match. What graph?
The graph, like if you graph the function.
Oh, yeah. You graph the function. Sure. I would say, yeah, but I would get in the habit of doing it from the home screen. But yeah, since you happen to have the graph or the equation of the function, if you went to Y1, you could hit second trace, which is your calculate menu, right? And then number 6, and then type in a 3. Yeah. You get the same answer. Yeah. Okay. Any other comments or questions? Good stuff. So far, so good. We're doing everything right. All right. A second particle. What the? Also moving along the x-axis, whose position is given by this much easier looking equation from 0 to 3.5. At what value of t are the two particles moving with the same velocity? Same velocity. Well, I need to set their velocities equal to each other, right? Now, I don't have, I need to take the derivative, and here's where I'll need the equation. So this is pretty easy, right? X prime sub 2 of t. I'm going to call that v sub 2. That equals 2t minus 1. So now I can say v of t equals v sub 2 of t, and that would get a check for showing the equation you're solving. Now, oh, yeah. You can have it with or without. There we go. So now what I would say is anytime you're trying to solve an equation, unless you know what the graphs look like, I would get everything on one side and set it equal to 0. So I would say v of t minus v sub 2 of t equals 0. Okay. And then I would put this into y1 or y2 or wherever, and then we already have 0 graphed. So back to y equals, I'm just going to come here at the end of y1. And notice I'm changing what's in y1 now. So what will be in y1 is no longer just v of t. And then I'm going to put minus 2x minus 1. Minus 2x minus 1. And I almost got away with that. Minus 2x minus 1. If I now hit, is that right? That's dangerous. Because notice, I need to put that in parentheses or distribute the negative. Minus 2x plus 1, right? Because I'm subtracting the quantity. That was close. And now I hit graph. And now I'm looking at the x-intercept again. So there it is. I've had my equation, and now I just put t equals second trace, number 5, enter, 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 and we get 1.570 seconds. You would need that trailing zero, or t equals 1.571 seconds. There you go. Unless you have trailing zeros forevermore, that third zero is part of the accuracy of the answer. Okay. All right. Have a good lunch. Be careful when you're subtracting quantities.